Let's try to understand recursion in a simpler way. For me personally, recursion was the word when I myself was afraid a lot back in college days. And so this time, while I was brushing my Python skills on my way to AI ML, I came across this concept called recursion. So in this video, we'll be practicing recursion with examples together. You can do lively together practice code along with me on this concept called recursion. Now, this recursion concept is not new or not specific to programming, right? It's you can see this concept in maths as well and any other areas as well. Now, what I'm going to do in this video is that I'll try to explain what is recursion in very briefly because the immediate term comes whenever we hear recursion, which means okay, we are calling the same function again and again. That's true. So basically there is a one function which generates one image of kangaroo. So it's again this function has been called. It generated first image of kangaroo. Then it again call the function. Again call not the function, but it again calls the same function. It generate again the image of kangaroo. It again call the same function. It again generate the image of kangaroo, and so on. Which means every time whenever you call the same function, but you see the behavior is changing. Now you might be wondering, hey, we are calling the same function, ultimately it's the same code, but how can the behavior is changing? So you change the behavior of, ultimately you change the behavior by passing the different parameters. So that's why maybe you might be passing a different size. So whenever you call the first time function, you give some size x, then you give some size x plus 1 or x minus 1. Then here you are giving x minus 2, here you are giving maybe x minus 3, and so on. And so this is how you alter the behavior by calling the same function. So all this mention the same thing. Now, before we get deep dive into the code level in Python, I really went through one of the article from University of Utah. So this is the article. I'll just put the link for your reference if you want to read for your own pace. So basically what they say, I really like the definition what they have put up. What they are saying, recursion is nothing but you basically ultimately you are trying to solve the problem, right? So in code, we always try to solve some problem. Now in recursion, what you do is you ultimately, whatever the problem that you are solving, right? You ultimately try to define the same problem in terms of itself, which means you want to solve some problem. Now to solve that problem, you are not coming up with solution. In fact, your solution to solve that problem is nothing but a simpler version of the main problem you are solving. So I hope I'm not confusing you. But what it simply says is that this is a very powerful tool. So which means you are trying to solve the problem by representing another problem. And so the goal is that ultimately you will try to reach to your main problem by solving the simpler version of the problem. Then again you solve the more simpler version of the problem, and then ultimately you reach to the main problem statement solution. For example, this example what they have given. For example, if you want to find your way to the home, right? So for that, so this there are the three steps you will do. So first step is that okay, if you are already at home, stop moving, which means you are already at home. You do not need to find your way to home. So because it's recursion, which means as I mentioned, you will always call the same function, right? Now if you do not have the exit condition, then you will end up always calling the same function again and again and again and again. What I'm saying, yeah, but again. So there has to be some exit condition where you feel that okay, I have solved this problem, I do not need to call this function again. So that's what we call it as exit condition, or sometimes it's also referred as base case. Base case is nothing but now you reach to your solution, you do not need to call the function again. So this is so the problem is that here the problem statement is that find your way to the home. So you want to find your way to your home. Now if you are already at home, stop moving, which means you're done. Now if you are not at home, right, then you will take one step toward the home, right? So you will take one step toward the home, and then again you call the find your way home. So again, you are calling the same function. So imagine the function is written like this, right? So the function is it's basically three-step function. The first thing is that you want to find your home. Okay, first you check whether you are at home already or not. Yes, you are at home, don't do anything. But if you are not at home, then take one step. Then again you are calling the same function, find your way home. Then again you are checking. Are you at home? Are you at home? No. Okay, take one step. Then again you call the same function in third step, right? You are at home? No. Okay. Take one step closer to the home. So here, if you recall this step two, right? The reason I said this multiple times, because then you can understand how in recursion you are trying to solve the problem by simplifying the main problem. Every step, in every step, you try to simplify your problem so that you ultimately reach to your main goal. So for example, here if you see the step number two, right? So in step number two, that is not a base case. Base case is something where you stop calling the function. But now in step two, what you are doing is that here you have not find your way to the home, right? What you are doing is that this is not a final solution, right? What it just says, okay, take one step toward home. Take one step toward the home. So you are trying to closure. You are trying to move closer to the problem. That's what it does. Your ultimate problem is that finding your way to the home. But by taking one step on every function call, by taking that one step, and then you check, okay, did I reach? No. Take one step. Did I reach? No. Take one step. So, did I reach and take one step? Did I reach and take one step? Those two lines are statements of my function, and where this function is solving the problem of me reaching to the home. I know this was a bit very longer. If you already know recursion, please, I mean, feel free to skip the video at all. But I'm just trying to break the things for the people who really had came across this recursion word, either they love or either they hate. That's how the recursion word is, because I was hating very badly in my college days, but now I'm loving it because the pattern, the beauty with which it solves the problem. So let's go to the example. So what we will do is, so I'll directly jump to the code. But before I jump to the code, what I was trying to tell you is, I think it's here. So what I was just trying to tell you, in recursion, you will always try to solve the problem by these two terms. One is base case, which means you need to identify when you want to come out from the function calling loop, which means you do not want to call the function again, which means you found the solution. And second thing is recursion case, which means you try to solve the problem by again simplifying the main problem. So again you try to simplify your problem, right? You always try to simplify the main problem at every step. So again, you are calling the recursion function. So for example, if I do over here, or rather let me go to the code window and let's try to solve a very simple problem. Uh, let's see if we can do yeah. So basically, let's see recursion with sum of natural numbers. Okay. So what we are going to do is, so here, what I want to do is, yeah, I'll just clear. So here we want to basically do the sum of natural numbers with recursion. So our problem statement is, so if I look like this, so the problem which we are trying to solve is that find the sum of n natural numbers using recursion. Here we are not going to use loop or anything. It's just with pure recursion we are going to solve this problem. Now n is nothing but its user input, right? Hope you got the point. Now to solve this problem, as I mentioned, there will be base case and there will be recursion case. Base case is something where you will just stop calling the recursion function. Now, ultimately, we are going to use the recursion, which means we need to have the pattern of calling the same function again and again, right? So let's try to understand how we solve this problem using recursion. So I want to find a sum of n natural numbers using recursion. So for example, user is giving n as like 5. So which means user is looking for a sum of first 5 natural numbers. So let's try to understand the problem, right? So if user has given input 5, which means user is expecting, hey, give me the sum of first 5 natural numbers, which means 1 plus 2 plus 3 plus 4 plus 5. And the sum will be 2 plus 1 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 15. So output should be 15, right? Now we will be solving this with recursion. Now how, so far you understood what is recursion, why we do, and what is base case, what is recursion case. Now let's try to write the steps. Let's try to understand how we can write the code, right? So here is the important thing we are now starting on. We will try to understand how we write the code so that we can solve the problem. Now for this, to solve the problem using recursion, understand this. For example, this is a function. So I will not directly write a code. So I'm just writing f as a function, right? And this is, it's like pseudocode I'm writing, right? So f and n. So n is like you want to compute the sum of n numbers. So for that, you should always and always understand that, okay, this function is already available to me. So when I say available to me, which means the function is already defined. So this is very contradictory thought, but then you have to always understand this way that, okay, the function which will solve the n natural number, that function is readily available, which means this function is already doing the sum of, this is how you try to solve the problem. So 1 2 3 4 5, and then dot dot dot. Ultimately we are reaching to the n, and there would be the term, right? There would be n minus 1 term, and then you reach to the nth term, right? I'm just trying to write this as a generalized form. Hope you get the idea, right? So we are trying to do the sum of n natural numbers. So this function, right, this function does the sum like this. So it keeps on adding. It starts from 1, then 2 3 4 5, and then ultimately reaches to the nth term, right? So ultimately it reaches to the nth term. Now before nth term comes, right, if I want to, because I'm generalizing here, right? So here, before writing n, I'm just putting n minus 1th term, right? That's how it would be. Now imagine that you have this function is already ready. Now ultimately I need to find a base case, and now I need to find a recursion case. Recursion, which means again I'm calling the same function. So right, that's what I'm trying to do. But here, how I am calling the function. So ultimately, when you write a recursion case, you always need to understand that how you would write this so that you will reach closure to your original problem statement. So again, you will not write the code itself to do the sum of n numbers, right? Because what I just mentioned, that's, imagine that you already have that solution is ready, which means you already have that function is ready. But to solve this problem, right? To solve the sum of n first natural numbers, you need to simplify this problem. Which means if I want to do the sum of n numbers, can I do a sum of n minus 1? So I'm just trying to break the main problem statement into the simpler one, right? That's how we give the solution, or that's how we define the recursion case. I am in step number 2. So here, to solve this big problem where I need to sum when I need where I need to do the sum of first and natural numbers, first I need to break this problem. So what I'm thinking is that, okay, if I want to do the sum of n natural numbers, which means can I do a sum of n minus 1? And then, so once I have sum is ready of n minus 1 numbers, right, up to here, then to reach the problem of sum of n numbers, I just need to add the n to it, right? So what I'm trying to say is, if I have this ready, if I have this, which means if I have this function is ready, which does the sum of 1 plus 2 plus 3 plus 4 and so on, right? You can just write on and on, right? And then it will do the sum of n minus 1. But then if I want to solve the problem, the main problem is n, right? The n natural terms. So what I'll do is, so how can I reach, how can I achieve this solution? So with this function, with this guy, I was able to solve, I was able to do sum up to here, right? So what is missing? I just need to add n. You see this plus, I need to add n, which means, which means fn is equal to solve my problem, I just need to add n to this guy, right? Now here if you see, we are doing recursion, right? So here ultimately you are calling the same function. You see here, so to solve this problem we are calling the same function which is f but with different arguments. So every time we try to reduce, we try to reduce this n number by 1. Now just stay with me. So let me keep it here. Now let's write the code. So for example, here I define a function in Python. So I'll put f def and then I put some n natural numbers, right? And this is the n which will be provided by user. Now what I'm going to do is, now for this, I'll call, sorry, I shouldn't write f. I'll call the same function because ultimately it's recursion, right? So I'm calling the same function. What I'm doing is that some n natural, I'm calling the same function over here. But as I mentioned here, I'm not solving the full problem. Recursion, which means you do not solve the full problem. You try to solve the, you I mean, what I'm trying to say is that you try to make your problem simpler. You try to make this main problem simpler. So instead of solving the problem till nth term or till n terms, let's do a sum of n minus 1. Now when you write this, remember this point. This is very important. So whenever you write this, that okay, I have simplified this problem by doing this sum of n minus 1 natural numbers, which means you do not need to think how this will be done. You just don't think how. Imagine that this is already working. This is already taken care. So which means this function is already doing sum of n natural numbers, but not n, but this function is already doing sum of n minus 1 natural numbers. So this implementation is already there. You do not need to write a code, right? So it's already there. Now what you need to do is, you need to do basically to solve the main problem, right? Imagine, right? So ultimately you want to solve this guy, right? So you have to add n. So far you did sum till n minus 1 terms, right? But then you did not add the nth term, right? Now nth term is nothing but this is n, right? So you simply need to add n to this working solution. Imagine this is already working, right? That's what I mentioned. So what I'll do, I'll just simply put n, that's the last term, right? So how you will arrive to the last term, right? So last term is n. So what I need to do is, if I have if I have a function which is already doing sum till n minus 1th term, right? It's already doing, it's already adding this term as well, right? Now to reach this fn, right, after n minus 1, of course the n comes, right? So I just need to simply add n. So that's what I did, right? So here I'm calling the recursion and this. Now we need to define a base case, right? Otherwise this function will keep on calling. So here what we will do is, here what I'll do, so every time we are decreasing the number, right? So for example, so to arrive to the base case, let's understand this more deep level. For example, you want to do a sum of four natural numbers, which is 1 plus 2 plus 3 plus 4, which is 2 plus 1 3, 3 plus 3 6, 6 plus 4 10. So output should be 10. Now how this function, so let's try to understand how this function will execute in memory when we pass the value 4. Then we will be try to arrive at base case, and then you will be able to understand what we are doing. So, and this is what you should be doing. Just take a pen and paper and try to understand very deep dive, right? So what we will do, so imagine I have passed F4, which means what it's going to do is I'll just copy this guy so that it would be easy for me. So again, this function will be called as 4, and then I'm not putting if condition as of now, but then what it will do is n plus n minus 1, which means, right? I'm just putting here 4 plus, I'll put it like this guy. So 4 plus, how this line will be interpreted, right? So ultimately 4 plus 4 minus 1, right? You got it right, what I'm saying here. So which means n minus 1. So here I just replace 4 with the n over here, right? So 4 plus sum of n natural, so n minus 1, which is 4 minus 1 sum of 3. Okay, and then actually I need to return as well this guy, right? So here what I'm doing is return. Okay, now I don't know what is if condition, but I'll tell you. I mean, let's do it together. But what I feel is because every time we are reducing this number, so from 4 to 3, then 3 to 2, 2 to 1. So let me put it like if n is greater than 0, let's run this. Okay, like this. Okay, and so what I'm doing is, so here what I'm doing is that, so for the first time when I pass f as a 4, so 4 comes over here, and here what we are doing is return. So here I'm just explaining, right? The 4 I just try to substitute for you just to explain. So this is how the function will execute. So for when n will be 4, so here n is 4, right? I mean in this case, so I'm just writing that n is 4. Then it will go to over here, it will come to this line, then it will say okay, 4 plus sum and n natural 3. So it's again calling the function. So flow from here, sorry, before that it is checking if n is greater than 0. So n is 4, right? So what it's checking, okay, 4 is greater than 0, yes. Then what it will do is it will do 4 plus, again calling the same function, but this time it will pass n minus 1, it will pass the 3 value. So let's go to the next. So again, it's calling the same another function, right? So now this time n is 3, right? Because here 4 is greater than 0, then you are calling the same function again and again, but then with n minus 1. So 3 comes. So this is 3. Now n is greater than 0. So which n? So here you are referring to n in this block, right? You are not referring to n over here. So n is 3. 3 is greater than 0. Yes. Then what it will do? So it will do 3 plus some n natural n minus 1, which means it will do, I mean over here if you want to interpret like this, 3 plus some n natural, it will do n minus 1 2, right? So now n has become 2. Now it will come over here, right? So now some n natural 2, right? So now n has become 2, which means this is 2, which means this is 2 minus 1, which means it's 1, and which means uh, I'll put it n, so 2 plus. Okay, so again, so imagine all these calls are get going in sequence, right? Hope you're able to understand, right? So we call this function with value n as 4. It check if condition, then it checks this line. Now here this line is calling the function. So it simply goes here, right? So it again calls the function, but this time instead of 4, it calls 3, right? So that's what I'm trying to tell. So here the function was called, it went over here, n is equal to 3, 3 is greater than 0, yes. Then what it do, 3 plus, again calling the same function, but this time 3 minus 1, 2. So it come over here. So that function call is literally going into the stack, right? So that function call is park. So this function has not executed fully. So this function it called now with argument 2. So again the same function is getting called with 2. So here in 2, then what you do is 2 plus sum of n natural function, which means now 2. Here we are calling the same function with argument 1. So what here we will do now, n value will be 1. N is 1. 1 is greater than 0. Yes, 1 is greater than 0. And here now we are calling function with sum and natural 0. This is 1. Okay, now we are just calling function and function and function, but not us, but the function has not ended yet, right? So now again this resulted into the one more function call, which means again we call this function with 0, n as 0, right? So n is 0, n is 0. Now here 0 is greater than 0, it's false, right? So now here we are reaching into the false condition. Now in this case, what I'm going to do is, because now I'll return 0. I'll tell you why. Because ultimately we want to do the sum, right? So here I'm just giving random value as 0. Not random, I cannot give 1, I cannot give 2, 3, otherwise sum will be unnecessarily bump up. Unnecessarily it will be added by 1 or 2, right? So here I'm just adding value as, I'm just returning value 0 when n is not greater than 0. So now let's understand all this. Okay, so now I mean so far I just explained, but let's again go through one more time. I know it's pain, you might feel, oh, it's very long video, but when you understand this whole flow, what's happening behind the scene, then you will be able to solve any problem with recursion. So in this video, I'm just going to end my video after solving this problem, so that I want to make sure you get the fully idea. Now let's run through all this again and again, right? So what we are doing is that, so we added else as written 0, right? So what I'm going to do is I'll add this to here, else 0 if n is greater than 0. So here I'm putting else as 0, here I'm putting else as 0, and here I'm putting it. Okay, so you are calling this sum and natural with 4, which means you want to do the sum of 4 natural numbers count summation. 4 is greater than 0, no. So it goes over here, it's simply return, but then before it return, right, it's calling this function. So it's calling like 4 plus sum natural 3, right? So it's again calling the function sum and natural 3. So now this function gets called. So sum natural 3 is nothing but sum natural 3, right? It come over here, 3 is greater than 0, yes. It will come to over here, and then it will again call the same function sum and natural with 2. Okay, then again sum and natural 2 is getting called. Now here in the sum and natural 2 gets called, then again you are checking 2 is greater than 0. Yeah, 2 is greater than 0, then what you do is 2 plus sum and natural 2 minus 1, so which means sum and natural 1, so which is again you are calling the function. So same way you will reach over here. Now when n is equal to 0, ultimately you will reach, ultimately you will be calling the same function with n argument as 0, right? Now over here what you will do is, here you are comparing n is greater than 0. No, it will go to the false. So which means here you are returning 0. Which means this guy over here, right? Understand this, understand this. Which means this guy is returning 0, right? So this guy is 0. Which means ultimately this guy, this function was called at here, right? So ultimately now here we are returning, right? So the moment when you return, it will go back to the line where it was called. So sum and natural 0 was called at this line, right? At this line. So it will go to over here, and then it will go to over here with this return value, right? So sum and natural with 0, right? So this function with 0 argument returns 0. So this value is 0, right? So this guy will be replaced with 0, right? Which means This will be evaluated with 1 plus 0. So now, so 1 plus 0, right? This is what we are doing. Now, so ultimately, so this output of this sum n natural 1 is nothing but 1 plus 0, which is 1, which means sum n natural, output of this function is equal to 1, right? You're with me. Now let's understand where this function was called, sum n natural 1. Yeah, it was called from here, right? 2 minus 1, you called over here. So this 1, sum n natural 1 is nothing but 1, right? I mean, this function, when you pass with 1, the value is 1. So you simply replace this. So you will be ultimately replacing this value with this one guy, right? Which means 2 plus sum of n natural 1. 1, what is the output of this function? 1. So 2 plus 1. So which means 2 plus sum of n natural, sorry, not 2 plus sum of n natural. Ultimately, you are returning this guy. This means 2 plus 1, 3, right? 2 plus 1, 3. So sum n natural 2 is 3. Now where this function was called, it was called over here, right? You see over here, sum n natural 2 is equal to 3. So you simply replace this guy with 3, which means 3, you're already adding 3, right? So 3 plus, the output of this is 3, right? So you put 3, which is 6, which means the output of this function is nothing but 6. Now, from where this 3 was called, right? So this function, basically this function was called from here, right? Here, so you simply replace, so this is the return value is 6, right? So you simply put over here, instead of sum and natural, the return value is 6, right? So you put it like 4 plus 6 is equal to 10, and the output of this is 10. Wow, it was a long battle, a long chain of thoughts. If you had really followed with me, you must have got idea, because now this is the final output which this function, because we had taken n as 4 and we got the output as 10. So this is how all the function got executed in those chains. Now let's try to write the code. So, so our base case is if n is greater than 0, then you keep on calling this function again and again, again and again, again and again. But if n is not equal to 0, right, which means it's a base case. Now we do not want to call this function again and again. We simply return 0. Okay, and then what I'm going to do is I'll now put the user prompt. So I'm converting back to the integer, and here I'm putting enter number of terms you want to do sum for. Okay, and here I just call sum a natural function with the n, and actually I should be printing, right, because it will print the values. And then let's test it, and then I'll tell you the secret one more time. Basically, you don't need to think all this. I just try to tell you all this because you need to understand how this works behind the scenes. But ultimately to solve the problem with recursion, how we arrive to this line, I would like to just repeat by the end of this video. So stay tuned. Now what I'm going to do is let's run this function program. Sorry, recursion sum natural pi. Okay, how many terms you want to do sum? For example, let's test with 4, right? 4 terms, right? That's what we did. So 4, yeah, you can see 10. For example, if I say first 10 terms, I think it's 55, right? Yeah. So it's just working, right? So basically, again, to summarize, what we need to do to solve any problem with recursion. For example, we are solving this problem 1 plus 3 plus 4 plus 5 plus 6. For example, I want to get a sum of 6 numbers. So for example, here, if I do over here, I say 6, the sum is 21. But then to reach to 21, how I code this or how I try to solve this problem is what I'm simply doing is that Can you do the sum of this guy? I don't know how. But yeah, I can do, which means I have, sorry, it was here, right? Yeah. So if I want to do the full summation rather than solving the full problem, can I solve the some simpler version of the problem? I would say, yeah, I can do. So which means let's do the sum of, sorry, why it's going there? I don't know. Yeah. But let's do the sum of 1 plus 2 plus 3 plus 4 plus 5. This is a little bit simpler, which means at least I was able to do the sum of this guy, which is nothing but, I think, 2 plus 1, 3 plus 3, 6, 6 plus 4, 10. It's 15, right? But I have not reached to the 21. So to reach to the 21, what I need to do is, I just need to add last term to this guy, right? To this solution. So 15 plus, I just added the last term, which is 6. So this is what I did. So I just added the last term, which is nth term, if I call it, and then I'm reaching to the solution. So that's what I was trying to do. 1 plus 2 plus 3 plus 4 plus, instead of saying 5, right? Here I am doing n minus 1 and plus n. So I already did sum till over here and I just added n. So I already did sum till n minus 1. I just added the last term. And that's how it's working. I know it was a long video, but then the idea was that just to make sure that you understand the recursion problems. Now, if you really have understood this problem, I want you to let me give one more problem before I end the video. I want you to work on the problem where using recursion, can you print the n numbers, which means if user enters say 10, which means you need to print the first n natural number. So if user enters 10, you will print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If user enters 15, then you print 1, 2, 3, and so on up to 15. So you will be just simply printing those numbers on the screen. And let me know if you have found the solution using recursion, not with for loop or while loop. So that's all. And if you like this video, just let me know, put some comment that you really like it, or put comment if you really do not like something. If you put it comment, then I'll get more idea. Okay, this is not something you like it, then I can explain more. I just tried my best. It was very long, but tried my best to explain this in very longer way. Thank you for now. See you, my dear